Welcome back to the Backyard Machine Shop. Well, it's another hot, humid day here in South Georgia, and I'm out here in the shop working. So, if you like seeing fat guys sweat, welcome. You might enjoy it. Well, finishing up the wiring on the 15-inch Rockwell drill press. I decided to go with a VFD on this unit. It's got a three-phase single volt 208 motor. So I run 240 volts here in the shop, and my phase converter puts out a little stronger than that. So just to protect the motor, I decided to go with a VFD. That way I can control the voltage. Also, it allowed me to control speed, and it allowed me to work with the speeds and RPMs on the motor. So when I get it set up, I'm going to set it up, it's going to have a wide range of speeds. I've got it here in the wood shop. This is where it's going to be at home at. So really and truly, it's going to be a good woodworking drill press. Alright, so what I got here, we're fixing to program this, and I wanted to kind of show you the program because we're going to have to change a little of the parameters in it for it to run 208 volts. So I've got a book, and I went through the book, and I've already put in what I needed it to do. It's a real simple job programming this thing, so if you'll hold on, we're going to power it up, make sure we can get power on it, and I'll go over a little bit of what we got going on. Let's see. Here's the closest one. Alright, here's what we got. Now I've got this drill press set up. I've got a power disconnect here. It's a 20 amp double pole 240 volt rated switch. This is going to be a disconnect for the VFD. So all it's going to do is turn the power on and off to the VFD. So we've got it wired to the VFD. So we're going to use the momentary switches in the drill press. It originally came in the drill press. We're going to use it to control the VFD. So it's going to start and stop just like it normally does, and the way it's done is you wire this just like you do a starter, except for the VFD itself has a couple of plugs, certain plugs you have to plug it into for it to work. And for you that don't know the way a momentary switch works, let me get over here and zoom you in a little bit, see if I can get you zoomed in. The way a momentary switch works is you have usually the start button, see if you can see that. Usually the start button is a normally open switch. That means that while it's in its normal resting place, it is an open circuit between it and its counterpart. Okay, the stop switch is a normally closed. You'll see it listed as NC. This one will be listed as NO, and what that means is that it has a circuit. It's closed switch is making a circuit between it and its counterpart. So when you wire starter, or in this case a VFD, you're bringing in a lead from the VFD, which is the common, it's the CM port on the VFD. Comes in here, so you've got it energized, and if you look, it's got a jumper. Some of them you have to put a jumper in, but this one already has a jumper in it, so it's energized here, and then it's energizing this this side of that pole. So what happens is when you press the start button, it closes its circuit. It closes its circuit, which energizes this wire, and this is called a latching circuit, or the start circuit. I guess this one would be the latching. So this goes over and it tells the VFD to start, and at that point the VFD knows that it already has energy on this circuit, and this is your latching circuit. It'll stay energized and drive the motor until you break that circuit. So that's kind of how the momentary switches work. I'm not an electrician, but just trying to explain how we wire these up. Okay. So if you look here on the VFD, let's see if we can get you zoomed in there. You have your common circuit, then you have D11, which is your start circuit, and you have D13, which is your what I would call a latching circuit. So all that's wired up, and we're fixing to do the program to tell that what it's going to do. Okay. Let's see if we can get you in here on the VFD itself. All right, so check through the book. We've got everything wired like it should be wired. I'm not going to tell you too much about that because I'm not an electrician and I don't want to. You need to get somebody that's qualified to do that. So we'll turn on the VFD. It should power up. There it goes. All right. So the first thing we want to do is we want to program. So we want to program, the first section will be the parameter setting, which will be P0. So we'll hit program and we got 0. Okay. So you hit enter again and it'll give you your what you need to program. So P00 is the motor nameplate voltage. This is what we need to change. So if you hit enter, it's going to give you 240 volts. So that's what this is. The default setting in this computer is, or in this VFD is 240 volts. So what we want to do is we want to set this down 230, 220, 208 volts. So that's what it's going to drive this motor at, is at 208 volts. So we hit enter and that's done. Alright, so 001, which is the motor nameplate amps. So we'll look back here on the motor, and I've got it all written down here. So it's 3.2. So we'll hit enter, and its default is 4. So we'll set it down to 3.2. And that way this will thermally protect the motor just like a starter or set of heaters will on a starter. So we hit enter again, that one's done. Okay, the motor, and the next one would be, enter this one, it's the motor base frequency, which in this case is 60 Hertz. And that's what this motor is. So we can leave it alone. Go to the next one. Okay, 03 is the motor base RPM. Now, this is a 1750 motor, so we're going to run 1750. That's what it's set at. We'll leave it alone. Alright. Alright, the next one is motor maximum RPM. Well, electric motors, the bearings in them, they're rated. They can run 3450. They probably can run a lot higher than that. I've seen them run, you know, up 8,000 RPMs. We're going to tell this one that the maximum RPM is going to be 3450. So let's enter that. It's already in there. Okay. So we'll go to the next one. So I'm going to drive this thing somewhere around 150%. So it'll be somewhere around 90 Hertz on the top end. And that's how we're going to get our effective speeds. Okay, so we finished with the 0 parameter. So now we go into the P1 parameter. So we hit, again, we go up, P1, and we hit program. Okay. So this parameter is acceleration time. Well, I'm sorry, this is the stop method. And we have two choices. We have 0, which is ramp to stop, and 1, which will be coast to stop. So if you select 1, when you turn it off, it'll be just like a normal motor. It'll wind down until it stops. Well, we're going to keep it, we want it to coast, we want it to ramp to stop. So we'll hit enter on that, and we hit 0. So we already set there. Okay. P101, acceleration time. The default setting is like 10 seconds. Let's see. I think I'm going to do about 5 seconds. That way it'll speed up a little bit faster, but it'll also still be slow start. So if you hold this button down, it'll pick up speed. Alright, so we got it set for 5 seconds. Alright, deceleration time. Now this is braking. These VFDs can resistor brake these motors. Typically, you have to have, if you want, like for instance my Monarch lathe, I got the same type setup in it, but I have big braking resistors where it can dissipate the heat. This doesn't have that in it, so you don't want to stop heavy loads with just the VFD. You need to to put resistors in it. So we're going to stop this one though. We're going to put it, I got it set here for 5 seconds. They've got it set for 30. So it's basically winding down. So let's hold this down. We'll drive it down to about, come on, here it goes. Alright, so that motor should, we'll try it at 5. We may have to adjust that. Anyway, it's going to go from running whatever it is down to stopped in 5 seconds. That's pretty much everything I needed to set in 2. So let's go back to program. Okay. Alright, let's go back to now we need to go over to P2. We have a couple of things we need to look at over there. So let's go here. Let's see, 0, 0 is the starting torque. We're going to keep it at 0, just a general. Slip, keep it at default. Midpoint frequency, which would be 3. I think pretty much everything here we're going to keep default. So we need to go to 3 on our display. And here's where we do a couple other things that we have to do. This is where we're going to tell the VFD how to start up. So 300, this is your source of operation command. The 0 is operation determined by the digital. That's everything's controlled right there. Number 1 be operation determined by external control terminals. Keypad stop is enabled. So this is what we want. You can still stop it with the keypad, but you can use external devices to control it. So we want to go to 1, hit enter, and oh, I'm sorry, I did the wrong one. Hold on, let's see. Display back. We want to go back to 0 and enter. So we want to do 1. So it's already set in. Okay. The next one is already set, and third one is already set. So we're done. That's all I'm gonna really do with this right now. We'll go through and we can fine tune it later. So let's see, we can get back to end display. Here we go, we're back to it now. All right, so what we want to do here now, I got the motor connected, everything. Let's try the motor and make sure we run in the right direction. And so I should be able to hit this button. Now let me back you up. Okay, I should be able to hit the start button and the motor should start. Cool, here we go. Alright, that's the motor running. Speed it up. That's 120 hertz, that's 3,450 RPM. That's 60 hertz, that's its normal speed. And you can slow it all the way down to a crawl. Okay, so let's go back to 60 hertz. But this is the first time this motor's ran in 10 years. But I've rebuilt it, so it's got all new bearings in it. It's got a little bit of vibration. I think that's the pulley's probably a little bit out of balance. Alright, so now you can come through here and you can do 1,776 RPMs is what the motor's running. Okay? We're running 61 hertz, 1.9 amps. Now, if you put a little load on the pulley, you'll see that go up. See? Putting a little load on it, making it go up. So that's your amperage. And I'm not sure what that is. I have to look that up. 207 volts. Okay. So everything looks good. Alright, go back to H, 61 Hertz, slow it back down. Alright, so now I should be able to hit this red button. Okay, this red button should stop it, and it should stop it in 5 seconds. Okay, there you go. Alright, so we've got the motor hooked up. We've got the VFD powered up, all that's working good. We got it hooked up in the right places. So what I'm going to do now is I'm going to try to dry some of this sweat off of me. And I'm going to go ahead and let's see what we got left to do. I need to close this up, I need to close this up, and I need to close the motor up. So everything's running in the right direction. Pulley just did it a little bit. And I'll bring you back and we'll put the belt on it and see what we can do. Alright guys, we've got the covers on. Got well, need to take my heat gun and I've got all the wiring covered up with heat shrink. So that's probably the last thing I'm going to do. Got the belt, got an AX44. I didn't know what the belt size was, so in projects like this, when I can't find the actual replacement belt. The way I find out the belt size is you can measure center to center, pulley size and pulley size, and either you can do the math and calculate it out, or you can go to vintagemachinery.org or .com, I think it is now, and no, it's .org. And under tools, they have a calculation. You just put in your numbers. It'll tell you how long your belt needs to be. Then you click over to McMaster car. You look up how long a belt. It tells you what the size is. Order it. Next day it's here. That's the easiest way to do it. So, before I put the belt on, however, what I want to do is we're going to check for spindle run out. So, let me get my indicator and I'll be right back. Guys, here's what we're going to do. Got our little Nova set up here. Let's see, let's tighten that up. Find something. Alright, here's what we're going to use. Got a piece of carbide. It's a water jet nozzle that's worn out. So it should be good and true. Let's chuck it up in there. Tighten this up. Alright, let's take our indicator. Let's see how we finagle this thing. Alright, can y'all see that? Alright, there we go. Okay, let's put a little preload on it. Oops, sorry about the camera there. We got about 10 thousandths preload. Let's rotate our spindle. Let's see, we got 2 thousandths. So we got at an inch out of the spindle, we got about 2 thousandths run out. I'm sorry. That's a half thousandths. That's about a thousandths run out. Not. Yeah, about a thousandths run out, so you probably got about a half thousandths total. It's pretty good for a drill press. I've never tested one. I don't think that was that good. Let's see. Let's test it down here at the bottom. Let's off the load, preload. Let's see what we got. Down here we got maybe 1.5 thou. So I hope y'all can see that. So it looks like it's in good shape. All right, so now we're going to put the belt on it and go from there. All right, wait for the big moment here. Okay, here we go. AX44 belt. All right, so start down here. I'm gonna put it about midways. I'll get the RPM calculations on this thing before I stop the video. So let's see, tighten it up. I'm a little tired of that. Let's see, is that straight? Well, let's go down one. Let's see if it's the pulley. Yeah, I think there's a little bend in that shiv right there. All right. So here we go, guys. Everything's working good. Big thing is, oh, start another. Okay. Big moment, guys. We're going to start it up for the first time. Hope it don't blow itself apart. All right, so we got power. Look, turn the power on. I'm going to turn the hertz down. Okay, so got it at 0. Easy. Oh, there we go. Something going on funky with this pulley here. Let's go up. Couple more. what's happened is this thing's got that little brass plunger in there. Well, it's got a spring plunger that holds the belt tight, and then you tighten it up with this. Well, I had to remake all this, and I ended up making a brass plug that went inside. And I think the brass plug is wedged up, so I just got to break those. Let's try it again. Alright guys, we got the belt on. I had to make a little adjustment. But anyway, it's ready to go now. Turn it on. '60 hertz. Nice and quiet. And that's what's good about the VFD. Like I said, I use the VFD not so much to control speed, but I use the VFD to convert this to instead of a transformer to get this to 208 volts. And along with it came the ability to adjust the speed. So that's where we at, guys. You want it wide open. That's about twice as normal speed. What we got? We got the belt on, we put the cover back on, got all the electricals done. Fixing to drill the first hole with the drill press. Okay, so what I'm going to do is I'm going to move the camera in a little closer, and we'll knock this one hole out, and then we'll wrap this thing up. What I got here is I got a piece of quarter sawn sycamore, piece of scrap, 1-inch Forstner bit, and drill press. First hole in, I don't know, probably since the mid-80s. So I've had it for, I don't know, 7 years, 6 years, and here we go. Alright guys, there we go. First hole. Been christened. Okay guys, there you have it. First hole done. Drill press in place. I guess I need to find a good spot on the floor. The floor is a little uneven right there. Anyhow, we did a lot to this one. A lot of machine work, new handles, new stop rod, new plunger in the back, upgraded electrics, got it on the VFD. There you go. New belt. Couple things I still need to do. I I need to heat shrink all the wiring where it'll be nice and neat looking. Tie this wire back somewhere back here. Touch up some paint. Let's see. Nah, it won't look good there. Anyway, I need to find the right badge, put back on it. The badge I have is just so bad I didn't bother putting it back on. I need to find the right taper pin for the column. Another thing I've done is I machined the table, filled and machined the table, so it's good. The column is still a little pitted. Did the best I could with it, but it ain't gonna have any effect at all on this drill press. So, all in all, it's been a good build. From where it started from, and from what it brought me as far as luck for with other machines, I'm proud to own it. So, like I said, I tried to give it away three or four times, and nobody ever took it. Nothing's impossible. So, alright guys, I guess that's going to conclude the video of the Rockwell 15-inch drill press. And remember, hit the like button, subscribe to the channel, and leave a comment. I like reading the comments. From the Backyard Machine Shop, so long.